Greetings, math fans. All right, so this is day one of Calculus, Chapter 3A. Again, it's just kind of a little overview. We're going to spend a couple days on some of this, some limits and definition of the derivative. So some of the stuff is actually kind of a refresher of what we learned last chapter with limits. Okay, so I'm just going to actually refresh your brain here. I'm going to write this on top. The definition of the derivative, if you remember that, we have limit as h approaches 0 of f of x plus h minus f of x all over h. And remember what that is, math fans. It's really just finding the slope of a tangent line at a point. Okay, because what we're doing is, if you guys remember, I'm not going to redo this again here, but you basically are shrinking that value of h, which is the gap. Okay, you're shrinking that closer and closer and closer. So the secant line that we remember from back in the day becomes a tangent line, so we actually can find the slope at that curve at a certain value of x. Okay, so there's a lot of practice of just plugging into this limit formula, and you're kind of good to go. So you kind of just need to remember a little bit what's going on, and you should be okay. All right, so let's start with the first one here. We have f of x equals x squared plus 4x, x equals 3. I'm not going to worry about that x equals 3 until the end. So what we're going to do is we're going to do limit as h approaches 0. And make sure you write this every time. They're going to be looking for that. Okay? And then it's x squared. Well, what do I plug into x squared? Remember, I plug in x plus h into that x squared, and I plug in x plus h into that x. Okay? So it's going to be limit, and then we're going to say x plus h squared. All right, that's plugging that into that x right there. And then what do I plug into the x there? I plug again what's in yellow here highlighted, plus 4 times x plus h. Okay, then it's minus, and I'm going to put this in a bracket because we're subtracting two different things. What do I plug into that x squared? I just plug in, highlight this, I just plug in an x. Well, that's actually really, really easy, math fans, because truly what you're doing is just rewriting, this. So if I'm plugging in an x into there, it's just like saying, oh, x squared plus 4x. Okay, so again, I got my x plus h in both the x squared and the 4x, and then I just have my x in the x squared and 4x. And we divide that by h. Now, what's our ultimate goal here, math fans? Our goal is to get rid of that h. We can't have an h in the denominator because you can't, when it goes to 0, it's undefined. So our goal is to get rid of that. So let's keep simplifying here. Limit as h approaches 0, and it's going to be x squared plus 2xh plus h squared. You guys should be pretty good at that. Plus 4x plus 4h minus x squared minus 4x. All over h. Okay, let's keep going here. Limit as h approaches 0. Well, what cancels? The x squareds cancel, and the 4x's cancel. So we end up getting 2xh plus h squared plus 4h all over h. Okay, and then what can I do? Because again, I want to get rid of that h in the bottom. Well, on the top, I can factor out an h. So limit as h approaches 0 of h times 2x plus h plus 4 all over h. That cancels. Now I can do direct substitution. You can't do direct substitution if you're going to get a 0 in the denominator. Can't do that. But once the denominator is gone, I can plug it directly in. So do you guys agree? That's just equal to 2x plus 0 plus 4. Or 2x plus 4. And that, math fans, is what f prime. We call that f prime, by the way. I really didn't talk too much about that. So the derivative, as we learned before, which is a limit, but this guy here, we'll call it f prime. Okay, which is the first derivative. All right, just something. So let me write this out here. F prime of x is a function, and there it is. It's 2x plus 4. It's easy. So that's the first part of our answer. Okay, in the second part, they say, well, evaluate that at x equals 3. The directions, let's look back here. Use the definition of the derivative f of x, f prime of x, which is that. And evaluate f prime of x at the given value of x. Okay? By the way, I did want to mention, I put two types of directions on here. Use the definition of the derivative, find the equation for the slope of the curve. Because that's really what a derivative is. It's finding its slope of a curve at a certain point. Okay, or it's a slope of a curve and finding the function for that. That's f prime of x, and then you plug in, So f prime of 3 just means you plug it into the derivative. So 2 times 3 plus 4. So it's 6 plus 4 equals 10. And that's the second part. So that's the slope of the curve at x equals 3. The slope is 10. It's kind of cool. All right? That I can give you any kind of function now, and you take the limit, you find the derivative, and you can find the slope at any point on there. I mean, back in the day, you could only do slope of a straight line. That's all you could do. Okay, by using the yachts, right? y2 minus y1 or x2 minus x1. Now you can actually find the derivative of any quadratic, could be a rational function, whatever. You can find the derivative. It's kind of cool stuff, math fans. All right, so those are my two answers. All right, let's move on to number 2. These are all the same directions, so it's just a little tricky, but let's just keep going here. So limit as h approaches 0, and this is 2 over, and what are we going to put in that x? We're going to put x plus h. Okay? Minus 2 over, what are we going to put in that x? Just an x. So once again, I substituted this, I put an x plus h in there, minus that same function, substituting an x in there. Okay? And of course, that's all over h. So you can't do anything with it because you got an h in the denominator, but let's kind of manipulate it. How do I simplify this? Well, you guys should remember we multiply by the lowest common denominator. So it's going to be x plus h minus 2 times x minus 2. All over x plus h minus 2 over x minus 2. Okay? And that gives us, limit as h approaches 0. Of course, the x plus h minus 2 cancels, and we just get 2 times x minus 2 minus 2 times the x minus 2's cancel, and we get x plus h minus 2. And the bottom is just kind of large. It's h times x plus h minus 2 times x minus 2. All right, please don't distribute the bottom. If you do that, what happens, again, we're trying to get rid of we're trying to get rid of this h. If you distribute the h in the bottom, you're going to make it more challenging to get rid of that h. Okay, it's going to be kind of brutal. So let's keep going here. Limit as h approaches 0. And I'm just going to distribute that. So 2x minus 4 minus 2x minus 2h plus 4 all over h times x plus h minus 2 x minus 2. And what do you notice cancels? The 2x's cancel and the 4's cancel, which is perfect. Because now I have limit as h approaches 0 of negative 2h all over h times x plus h minus 2 x minus 2. And then the h's cancel. That's pretty sweet. So I have limit as h approaches 0 of negative 2 over x plus h minus 2 times x minus 2. And then what do? You put a 0 in for h. I can do direct substitution now, right? So let's do that. I don't need to write limit anymore because I'm putting it in there. So I get, if I put a 0 in for h, do you guys agree I just get x minus 2? And then I have another x minus 2 after that. So I wind up getting, and this is, I can call this f prime of x equals negative 2 over x minus 2 squared. Okay, that's your first answer. That's the derivative. And then if I want to find the slope of the tangent line at a certain point, and our certain point was 3, I just plug a 3 into there. So f prime of 3 equals negative 2 over 3 minus 2 squared. So f prime of 3 is equal to negative 2 over, right, 1 squared is 1, so it's negative 2. Okay, not that bad, right? It's really a ton of algebra. Ton of algebra. All right, let's do number 3 here. Same thing. Limit as h approaches 0 of 1 over, and we're going to put in there, we're going to put in x plus h squared, right? Minus 1 over, we're going to put in there x over h. Not bad. Okay, so the LCD is x plus h squared and x squared. So x plus h squared and x squared. So we get limit as h approaches 0, and then if I multiply the first one out, the x plus h squared cancels and we just get x squared. And the x squareds cancel, and I get x plus h squared. And on the bottom, I get h times x plus h squared, x squared. Again, don't distribute that h. Please, don't do that. That's very bad. Okay, so I get limit as h approaches 0 of x squared minus, if I distribute that, and make sure you distribute the negative. Okay, that's huge that people forget to do that. So it's minus x squared minus 2xh minus h squared all over h x plus h squared x squared. So I get limit as h approaches 0. The x squareds cancel. And what I'm going to do is I'm going to just factor. I know some people want to say, well, can I factor out a negative and everything? You know what? Don't do anything. Don't factor out a negative. Just factor out the h. So we get h, and then we get negative 2x minus h all over h x plus h squared x squared. So the h's cancel, and then I can, let me just write this again, limit as h approaches 0 of negative 2x minus h over x plus h squared x squared. Now, do you guys agree? When h goes to 0, I just put a 0 in there, so I wind up getting, I don't have to write limit anymore, negative 2x all over x plus 0 squared, or x squared, and then another x squared. So that gives me negative 2x over x to the fourth, which is negative 2 over x cubed. And that is f prime of x. Okay? And then, of course, I set at x equals 5, so f prime of 5 is negative 2 over 5 cubed, which is equal to negative 2 over 125. Okay, not bad. Let's keep going here. A couple more examples. Okay, this is one with a radical. Ooh, I like radical problems. It's very radical. Probably from California. Okay, anyway, let's plug things in. We have limit as h approaches 0 of, what we put in that for x, we put in x plus h, so it's the square root of x plus h minus 2, minus, what do we put in for that? We put in x, minus the square root of x minus 2, all over h. Sweet. Okay, how do we get rid of this one? Okay, well, we don't, it's not a, there's no denominator or anything, but if you guys remember, we multiply by its conjugate. So it's going to be the square root of x plus h minus 2 plus the square root of x minus 2. X plus h minus 2 plus the square root of x minus 2. Okay, so by the conjugate, it's pretty easy. So we get limit as h approaches 0. And then if I FOIL it, right, I get the x plus h minus 2's, the square root of those just gives me the square root goes away, right? So I just get x plus h minus 2. And you guys agree that the oi, or the outside and inside, cancel. And then we get minus, again, watch your parentheses. Right? It's minus parentheses x minus 2 all over h times square root of x plus h minus 2 plus the square root of x minus 2. That bottom looks a little nasty, doesn't it? Okay, but you don't worry about it, because you're going to plug a 0 in for h in a little bit here. But let's keep going. I get limit h approaches 0 of x plus h minus 2 minus x plus 2 over h square root of x plus h minus 2 plus the square root of x minus 2. Okay, and then, of course, the x's cancel. It's nice. And the 2's cancel. And we'll wind up with limit as h approaches 0 of just h, sweet, over h square root of x plus h minus 2 plus the square root of x minus 2. Okay, and the h's cancel. And then I can do a direct substitution. So let's just do that. I get 1 over, if I put a 0 in for h, I just get the square root of x plus 2, or sorry, x minus 2, plus the square root of x minus 2. So I get 1 over, remember when you're adding radicals, it's like saying radical 3 plus radical 3 is 2 radical 3. So 1 over, if I can add these together, right, because they're like radicands. I like that word. It's a good word. So we get 2 and then x minus 2 under the radical. And this is what f prime of x equals. Okay? That's pretty mellow. And then I asked you guys that x equals, I believe it's equal to 4. Okay, so if I say f prime of 4, I get 1 over 2 times the square root of 4 minus 2, which equals 1 over 2 root 2. Of course, you rationalize it, and we get f prime of 4 equals root 2 over 4. Okay? Not bad. Okay, we got a couple more examples here. Just a little more radical action. This one's a little trickier, and the only reason it's a little trickier because it's 3 minus x as opposed to x minus 3, but not that big of a deal. Okay? So we're going to do the limit as h approaches 0 of the square root of 3. Now this is important again. Don't forget your parentheses. So it's 3 minus x plus h, right? Minus the square root of 3 minus x. Because remember, I'm putting an x plus h in there, then I'm putting an x in there. And don't forget those parentheses. All over h. So we get limit as h approaches 0 of, here, I need to multiply by the conjugate, of course. Okay, I could distribute that now if I wanted. That 3 minus x, it doesn't really matter. If I do that, I get, well, let's just keep it consistent. Okay, plus the square root of 3 minus x. Okay, don't change any other signs in there. It's only this sign that is the opposite. Okay, it's very important. Okay, then over the square root of 3 minus x plus h plus the square root of 3 minus x. Okay, so then when you do the limit, of course the oi cancels, and you wind up just getting 3 minus x plus h, and then minus 3 minus x, all over h, square root of 3 minus x plus h, plus the square root of 3 minus x. Okay, close parenthesis. All right, and let's distribute the top. So limit as h approaches 0 of 3 minus x minus h minus 3 plus x over h, square root of 3 minus x plus h plus the square root of 3 minus x. And the 3's cancel, and the x's cancel. Sweet, sweet. Okay, better cancel, right? Because we need to be able to cancel the h out. If you got anything else out there, let's say the 3 was still on top, you know you did something wrong. Because you can't, if you got a 3 on top, there's no way you're going to factor out an h to have it cancel, and it won't work. All right, so limit as h approaches 0, it just gives us negative h over h 3 minus x plus h plus square root of 3 minus x. And then the h's cancel, of course. And then I'm going to plug a 0 into that. So I get negative 1 over, watch your signs, the square root of 3 minus, well, if h is 0, isn't it just 3 minus x? Right? Plus the square root of 3 minus x. Hey, I can combine those. So here, my f prime of x is equal to negative 1 over 2 square root of 3 minus x. Okay, so that's the first part. And then f prime of 1 just means negative 1 over 2, and it's 3 minus 1, which is negative 1 over 2 root 2. Rationalize, get negative root 2 over 4. That is what f prime of 1 is. Okay? Not too shabby. Okay, last example here, and then we move down to number 7. Same deal, just, it's a little bit bigger numbers and a couple of other extra things here. Okay, so we're going to say limit as h approaches 0 of the square root of 2. Remember what you put in for x plus h minus 4, minus you put an x in there. So it's basically just saying, if you notice that second part, math fans, is always, let me highlight this, that's always that second part right there. Okay, if I just even go up here, when I did the limits for the first thing, right? There it is, there it is. There it is, there it is. Because you're just putting an x in there. It's like doing the whole problem, it's like just repeating the original problem. Alright, so let's keep going here. This is all over h. Okay, and then we got to kind of squeeze this in here. But multiplied by the conjugate, so it's 2, or the square root of 2x plus h minus 4 plus the square root of 2x minus 4. Well, it's crunched in there. Whew. Okay, and then let's make a little more room here. Limit as h approaches 0. And if I FOIL this out right, of course, the y is going to cancel, and we have this 2 times x plus h minus 4. And then it's minus, don't forget the parentheses, that's huge. And we have 2x minus 4 all over h times, and then it's going to be square root of 2x plus h minus 4, and then plus square root of 2x minus 4. Okay, not a big deal. Keep going here. Distribute the top, so we get limit as h approaches 0 of 2x plus 2h minus 4 minus 2x plus 4 all over h square root of 2x plus h minus 4 plus the square root of 2x minus 4. Okay, and of course the 2x's cancel and the 4's cancel. Our goal always is to get rid of that, just have an h on top, or be able to factor an h out. And we have limit as h approaches 0 of 2h over h, the square root of 2x plus h minus 4 plus the square root of 2x minus 4. Okay, the h's cancel, and I can do direct substitution. So let's do that. and we wind up having f prime of x then equals 2 over. If I put a 0 in for h, I just get the square root of 2x minus 4 plus the square root of 2x minus 4. Sweet! So f prime of x, a little messy here, f prime of x is 2 over 2 times the square root of 2x minus 4. The 2's cancel, so we actually get 1 over the square root of 2x minus 4. Okay, that's f prime of x. And then if I do f prime of my value is 8, I get 1 over the square root of 2 times 8 minus 4, or 1 over 16 minus 4 is 12, which is 1 over 2 root 3, and rationalize it. There might be a Yox over in this corner here, so let me move this up. And I get equals root 3 over 6. Okay? Not too bad, not too bad. All right, last problem here, math fans. Given g of x is that and g prime of x is that, so this is a deal. We actually, before we always calculated this. Now I'm giving it to you. I'm telling you this is the slope. That's my g prime. That's the slope of the tangent line. That's the function for that. So a couple things. When, at what point, and notice I said point, that means I need an x and a y value. Does g of x have a horizontal tangent? What does horizontal tangent mean? Well, if I give you a function that looks like this, and I said a horizontal tangent, well, isn't it, here's a horizontal tangent right here. What's the slope of that line? Oh, it's 0. So what I need to do is I need to, my slope has to be 0. Oh, my slope has to be 0. Look at that. The slope is equal to 0. So g prime of x, so I need to set g prime of x equal to 0. So 8x minus 3. Don't plug in a 0 into x. I need to set it. G prime is the slope. So 8x minus 3 equals 0. So 8x equals 3. X equals 3/8. Now, if you gave me that as an answer, you would lose a point. Why would you lose a point? You would lose a point because you have not given me a coordinate. You have not given me a point. How do I find the y value? You plug it back into the original function. That makes sense, right? If I gave you a function, you know, y equals mx plus b, whatever, some function, I gave you a value of x, how do you find y? You plug it back into the original function. Don't plug it back into the slope function. Okay? Because actually, if you plug it back in the slope function, you get 0, because you know your slope is 0. All right? So if I do that, I get 4, and I get 3/8 squared minus 3 times 3/8 minus 1. Use your graphing calculator, use the fraction button on there, but you wind up getting negative 25 over 16. So your answer for this problem is your x value is 3/8, and your y value is negative 25 over 16. Okay, that's your answer. All right, so that's day one. Again, just as it's kind of just a brief idea of what the definition of the derivative is, coming up with a function now, and plugging that in and getting your solution, and understanding a little bit that f prime means slope of the tangent line. Okay, that's it, math fans. Have an outstanding day. Adios. Goodbye.